colossal, revolutionary, stupendous, a major achievement.
That's the enthusiastic response the keratometer received upon its introduction at the turn of the century. Now, almost 100 years later, this special instrument continues to be of importance to the eye care profession. This program is designed to assist you in competently performing keratometry. The word keratometer is derived from the Latin words for cornea and to measure. Aptly named, the instrument measures the amount of curvature of the cornea, the clear front portion of the eye. These measurements are a primary means for determining the base curve of a contact lens. The instrument is also used for contact lens follow-up and problem solving, as well as for screening of corneal health. Keratometric readings also indicate the amount of astigmatism, a common vision condition caused by irregular or misshapen corneas. Successfully performing keratometry requires proficiency in 3 key areas: testing, recording, and instrument calibration. To prepare for testing, switch on the instrument at the base of the lamp housing. The first important step is to preset the ocular to your vision correction. Turn the eyepiece fully counterclockwise. Through the ocular, slowly turn it back clockwise until the reticle is in sharp focus and stop. Do not rack the focus. Note the value that appears on the scale. Repeat this 2 more times, each time noting your stopping point. The average of your readings will be your preferred setting and should be used for future testing. Position the patient comfortably and securely against the chin and forehead rests. Swing the occluder down in front of the eye not being tested. To help establish a routine, always test the patient's left eye first. Rotate the axis barrel to 0 and reset the drums to their lowest power reading. Turn the height adjustment knob to line up the positioning pin on the barrel with the outer corner of the eye. To establish primary positioning, sight along the barrel and slowly pivot the instrument to center the white circular reflection in the pupil. Instruct the patient to sight down the center of the instrument and hold a steady gaze. It is common for them to report seeing a reflection of their own eye when properly fixating. Viewing through the ocular, the corneal reflection appears as a configuration of 3 circles, or mires. The lower right mire is known as the doubling mire. It appears doubled when out of focus. Use the focusing knob to bring all the mires into sharp focus. Pivot the instrument and use the height adjustment knob to center the eyepiece reticle in the doubling mire. Lock the instrument in preparation for taking measurements. Notice that each mire has a plus and minus sign. These signs must be aligned to obtain a correct reading. Rotate the axis barrel until the plus signs meet tip to tip. Slowly turn the horizontal drum until the plus signs overlap and stop. To maintain exact focus, leave one hand on the focusing knob at all times. Next, turn the vertical drum to superimpose the minus signs and stop. Observe the readings on the power drums and axis barrel. The horizontal drum value is read in conjunction with the horizontal axis value. In our example, the horizontal power reading, displayed in diopters and millimeters, is 42 diopters. The horizontal axis reading, displayed in degrees, is 170 degrees. Record both findings together as 42 diopters at 170 degrees. In similar fashion, the vertical drum value is read in conjunction with the vertical axis value. In our example, the vertical power reading is 42.50 diopters. The vertical axis reading is 80 degrees. Record both findings together as 42.50 diopters at 80 degrees. After recording your findings, take a series of 2 more readings to assure the consistency of your results. Repeat the same procedure for the right eye. Here are a few things to remember when performing keratometry. Maintain constant focus while taking measurements. If focusing seems difficult, reposition the patient and continue testing. Obtain readings quickly to minimize accommodation. Take multiple readings of each eye. Measured values should be within 1/4 diopter and 5 degrees of each other. All keratometers must be regularly calibrated to ensure instrument accuracy. Even a small deviation can cause a substantial error in final measurements. A calibration kit consists of steel spheres of a known curvature. These values are compared against your instrument's readings. If a difference is found, the power drums are readjusted to match the known values. Performing calibration offers additional benefits. It's an easy way for a new operator to practice the keratometry procedure. The standard measuring range of a keratometer is from 36 to 52 diopters. This is adequate for testing the majority of patients. For special cases, trial lenses can be added to extend the range of your instrument. Refer to your operator's manual for detailed information. This program has been designed to assist you in performing keratometry. Multiple viewings are recommended. Look forward to these additions to the CLMA video library in the near future. Diagnostic Fitting Volumes 1 and 2, the Radioscope, Lensometry, and Building Your Practice with RGPs.